Alright, so this video is going to go through solving radicals. We hit it on Monday in class, but I'm just going to work some more examples so that you can either stop and look at them, practice on your own, and check yourself, stuff along those lines. So the first one I'm going to do is a pretty basic one. 2 is equal to the square root of 3x plus 34. So our first step in these always is to isolate the radical. And remember that radical is whatever is underneath the square root. So that means I can't have anything in front of it, behind it, next to it. It needs to be by itself. And in this situation, it is. So once I've done that, what I'm going to do is I'm going to raise each side to the power that the radical is. So there is no number here because it's a square root. So when there's no number on a radical, you have to remember it's 2. So what I'm going to do is I'm going to raise each side. I'm going to put parentheses around each side, and I'm going to raise it to that number. So since this is the square root or the little 2's there, I'm going to raise it. I'm going to square each side. What that does on the left side is I have 2 squared, or 2 times 2, which gives me 4. And it's equal to, on the right side, I have the square root and it's squared. What happens is my square root symbol cancels out. It goes away. And I'm left with what's underneath that radical. So I have 3x plus 34. Now I need to do my steps to solve for x, so I'm going to subtract 34 from both sides. When I do that on the right, it cancels out. On the left, I have 4 minus 34. That leaves me with a negative 30 is equal to 3x. And your last step here to solve for x is to divide both sides by 3. So x is equal to negative 30 divided by 3 gives you negative 10. Now we're not done here. Your last step in these kinds of problems is to check them, because sometimes you will have 2 answers, sometimes you'll have 1 answer, and sometimes you'll have no answer or no solution. When you're plugging this in, you have to plug in back to the original. So our original was 2 is equal to the square root of 3x plus 34. Now I just found out what x was, so anywhere I see an x, I'm going to plug in negative 10. So when I start this, you have 2 is equal to the square root of 3, but instead of x, I'm now going to plug in negative 10. And I still have that plus 34 underneath. Now 2 is equal to the square root of 3 times negative 10 gives me negative 30 plus 34. 2 is equal to, I'm going to simplify negative 30 plus 34, and that gives me a positive 4. And now I have 2 is equal to the square root of 4, which does happen to be 2. So my answer did work out when I checked it, so x equals negative 10 is the answer. So now in this example, again, we're first going to see if the radical is isolated. I'm going to put a box around it. You want to check to see if there's anything in front or behind it, and there is. We have this 9 right here, and it's attached to the radical by multiplication. That's why they're stuck together. So to get rid of it, I have to do the opposite, which is division. I'm going to divide the left side by 9, and I'm going to divide the right side by 9. When I do that on the left, my 9's cancel out, and I'm just left with the square root of 4x. And it's equal to, I have 72 divided by 9, which gives me 8. My radical is now isolated, so I'm going to raise each side to the power, which is 2. When I do that, my radical cancels out and I'm left with what's underneath, so 4x is equal to 8 squared, or 8 times 8 gives me 64. And my last step, to divide the left by 4, the right by 4, and I get x is equal to 16. Now again, we're not done here. We have to plug it in. We have to check the answer we got. So I'm going to be plugging it into that original of 9 square root of 4x is equal to 72. When I do that, I have 9 square root of 4, and instead of x, we're plugging in what we just found x to be, which is 16. And it's still equal to 72. So you have 9, we haven't done anything with that. 4 times 16 gives me 64, and it's equal to 72. Now I'm going to take the square root of 64, and that gives me 8. My last step is 9 times 8, so that's 72 equals 72. This is a true statement, so x equals 16 is my answer. All right, so this next example is 1 plus the square root of k plus 1 is equal to 9. So again, I'm going to box my radical to make sure it's isolated, and here there is something in front of it. It's not stuck to it, it's being added to it. So to get the 1 to the other side, I'm going to subtract 1 from both sides. 8 cancels out on the left, and I'm left with the square root of k plus 1 is equal to 9 minus 1, which is 8. So again, we're going to raise each side to the second. We're going to square it. When that happens, my radical cancels out, and I'm left with k plus 1 is equal to 8 squared, or 8 times 8, which gives me 64. And my last step to solve for k here is to subtract 1 from both sides. So k is equal to 64 minus 1 leaves us with 63. Again, all of these you're going to have to check, so just get used to it. My original problem is 1 plus the square root of, and instead of k, I'm going to put 63 in its place. Plus 1 is equal to 9. So I have 1 plus the square root of 63 plus 1 is 64 is equal to 9. 1 plus the square root of 64 here is 8 is equal to 9. And then 8 plus 1 is 9. So 9 does equal 9, so this is true. That means that k equals 63 is our solution. Now in this one, I'm not going to talk through it. I am going to work through it though, so you can see what steps I'm doing and in what order. Alright, so this problem has a couple other steps, but it does say the same. We first want to isolate that radical, so if I box it, there's nothing with it, so I don't have to move anything, divide, anything like that. Now I am going to go ahead and square each side. When I do that, my radical still cancels out, and I'm left with negative 1 minus 2x is equal to, I have x times x, which is x squared. I'm going to move everything to the right side to keep my x squared positive, so I'm going to add 2x to both sides. And I'm also going to add 1 to both sides. It cancels out on the left, and I'm left with 0 is equal to x squared plus 2x plus 1. Now, whenever you have a squared like this, an x squared, you can do the quadratic formula, you can complete the square. I always check for factoring first. There is no number in front of my x squared or in front of my a term, so that means it's a equals 1. I'm going to look at that last number right here, my c, which is 1. So I'm going to list out the factors. It only has one set, 1 times 1. They need to add up to be 2, so they're both going to be positive. So I have x plus 1 times x plus 1. Now I need to solve these. Since they're the same, I only have to do it once. So I'm going to do x plus 1 equals 0. I'm going to subtract 1 from both sides, and I end up with x is equal to negative 1. So to check these, so we're going to plug it back into that original, the square root of negative 1 minus 2 times, and instead of x, we're going to write negative 1 is equal to, I also have to put negative 1 in place of this x as well. I'm going to simplify that radical. I get negative 1 plus 2 is equal to negative 1. The square root of negative 1 plus 2 gives me a positive 1 is equal to negative 1. And the square root of 1 here is 1. Now 1 does not equal negative 1. So that means x equals 1 is not a solution. I don't have any other options for answers. So this problem is a no solution problem. All right, so this is another one that I'm just going to work out. I won't talk through this one. All right, so this last example is the example that we did at the end of class Monday, and it's the example or examples that are going to be the worst out of all this. So we still want to isolate a radical, but we have two of them here. So you want to ask yourself, which radical do I want to isolate? In this case, it's easy to pick. You want to kind of isolate the one that has more underneath it. So I'm going to isolate the first time this one right here, which means I need to move this second radical to the other side somehow. And you want to think about it just like how you're solving equations. So in this problem, it is plus the square root of x. So I'm going to do the opposite, and I'm going to subtract the square root of x from both sides. When I do that on the left side, it goes away, and you're only left with the square root of x minus 3 is equal to, we have 3 minus the square root of x. I cannot combine them together. They're not the same. Now I've got that radical on the left side isolated, so now we're going to square both sides. When I do that on the left, it cancels out, it goes away, and I'm left with whatever was underneath the radical, which happens to be x minus 3, and it's equal to this mess now. You can't just go in and square each piece and call it good. You have to rewrite it out. So 3 minus the square root of x times 3 minus the square root of x. It's being squared, so that's why I wrote it two separate times. So for now, I'm going to leave the left side alone at x minus 3. But it's equal to, now we have to start foiling. So I'm going to do 3 times 3 first, and that gives me 9. I'm going to do 3 times a negative square root of x, and that gives me negative 3 square root of x. Now I'm going to multiply negative square root of x times 3, and that's going to give me another negative 3 square root of x. And finally, I'm going to multiply negative square root of x times negative square root of x. That gives me positive, and those radicals cancel out when they're being multiplied by each other. So again, we're just left with what's underneath, and I have a positive x. Again, we're leaving that left side alone, x minus 3. I asked myself, is there anything I can combine with this 9? And there's not another number by itself, so I can't combine anything with it. So I'm just going to rewrite the 9 down here. Now I want to look at negative 3 root x, and I can combine the other negative 3 root x with it. And that's going to turn into negative 6 square root of x, and I have the plus x on the end by itself. We now have another radical, so what we have to do again is try to isolate that radical. So I'm going to start moving stuff again. I'm first going to subtract that x from both sides. When I do that, it cancels out on the right, and it does happen to cancel out on the left as well. I'm also going to subtract that 9 from both sides. When I do that, it cancels on the right, but I have negative 3 minus 9, that gives me negative 12, is equal to negative 6 square root of x. Now my radical still is not by itself. I have that negative 6 in the front, so I have to divide both sides by negative 6. When I do that, it cancels out here. And I have negative 6 divided by 6, which gives me a positive 2, and it's equal to the square root of x. My radical is alone at this point, so I can square both sides. And when I do that, 2 squared leaves me with 4 is equal to x. So just like all the other problems, you still have to check your answers. And you check that with the original. So I have the square root of x minus 3, so 4 minus 3, plus the square root of, again we have another x, so 4, and it's equal to 3. So I'm going to do the simplifying. 4 minus 3 gives me 1, plus the square root of 4 is equal to 3. The square root of 1 is 1, plus the square root of 4 is 2, still equal to 3. And then finally 1 plus 2 is 3. And 3 does equal 3 in this situation, so 4 equals x, or x equals 4 is our solution.